This is somewhat of an easy example. Let's say calculate Q, which is heat, work, changing its energy and changing entropy for a reversible isothermal expansion at 300 Kelvin of 2 mole of a perfect gas from a volume of 500 centimeter cube to 1500 centimeter cube. So right off the top, we should know two things. We should know that delta U is equal to 0 and delta H is equal to 0. Why? It's given. We have isothermal expansion of a perfect gas, reversible. So pretty much temperature is constant at 300 K. So if temperature is constant, the delta U and delta H will be equal to 0. So now we have to calculate work and heat. So according to the formula, so we have delta U is equals to Q plus W. Delta U is equal to 0. So you have 0 is equals to Q plus W. W is equals to minus Q, which is equals to NRT ln V2 over V1. So this example is pretty much straightforward. All you have to just plug in what's given. So we're given moles, which is 2. And a gas constant, we have to use 8.3145 joules per mole. Why? Because work is measured in joules and heat is in kilojoules. So pretty much we have to use this formula for the out. And temperature is given, which is 300 Kelvin, and volume 1 and volume 2. So I'll pretty much just plug in everything and you should get approximately probably like 5 kilojoules or 5 point something joules. So let's work it out. So let's solve. So we have W is equals to minus Q, which is equals to NRT ln V2 over V1. So just plug it in. So we have 2.00 mole times 8.3145 joules per mole Kelvin times 300 Kelvin times ln of 1500 over 500 and cm cube, both cancel out. So this should be 3. So ln of 3 is approximately 1.0, 1.1. So this is 1.1 times 300 Kelvin. This cancels out. The mole cancels out with mole. So we have 2 times 8.245 joules times 300 times 1.1, because ln of 3 is 1.1. Because this is by this, you get 3. So when we plug it in, we should get W is equals to minus Q is equals to about 5,480 points something joules. Something joules. And our Q is equals to negative 5.5 kilojoules. Alright, we divide it by 1,000. So, like I said, to make sure that we get it correctly, if we plug in Q plus W, we should get delta U is equal to 0. Why? Because delta U is a state function and delta H is a state function. So pretty much delta U and delta H changes with temperature. And our temperature here is constant. So pretty much this is our answer. And that's it. Straightforward. So pretty much that's how you calculate heat, work, energy, and entropy in the process. So pretty much you have to read the question and see what's given and whatever it is, and just apply whatever formulas that you can apply to solve for the equations.